All right, folks, welcome to this earthquake edition of my live, usually weather and climate office hours, though occasionally other natural hazards do make it into the mix, and today is one of those days to be talking about the major earthquake off the north coast of California and the potential associated tsunami threat that remains ongoing. And while I'm talking today, I'm going to be looking at my own information off screen pretty regularly. And I'll be sharing a little bit on screen as well. So, quick recap as to what's happened so far. Within the past hour, a major earthquake did occur off the coast of far northern California, so southwest of Eureka. It's about a magnitude 7 earthquake, which is pretty strong, and also it was relatively shallow. I think 8 kilometers or about 5 miles deep. So that is an earthquake with quite a lot of energy that was actually felt at the surface. So the fact that it was a relatively shallow magnitude 7 is part of why the shaking along parts of the north coast was confirmed by accelerometers that the USGS has installed to be strong or even very strong. So there were very strong ground motions on land that presumably have affected people and infrastructure. This is somewhat similar to other earthquakes that have occurred in the last 5 or 10 years. There have been multiple major earthquakes in and near Eureka and Ferndale that have caused pretty extensive damage in some cases to structures and infrastructure. This may be another one of similar magnitude. No two quakes are alike. This one is a bit shallower, and it's fairly close to the coast, so your mileage may vary. Haven't seen damage reports yet, but I suspect there will be at least some, given that the accelerometers did measure very strong ground shaking from that M7 magnitude quake southwest of Eureka in some cases. The next point to report, there was initially reports of a secondary significant magnitude 6 earthquake near Cobb in Lake County, near the triple point of Sonoma, Mendocino, and Lake counties. It now appears that was a misinterpretation of the shaking from the single earthquake up off the coast of Eureka. So there was an earthquake near the geysers, or just northeast of it near Cobb, but it was not a significant earthquake. I believe it was about a magnitude 3, which is more in line with the shaking reports that were received. So that was due to a conflation of two nearly simultaneous earthquakes, but one, it turns out, was much stronger than the other not really a significant event to talk about. So today we are really talking about the large magnitude 7 earthquake near Eureka, the subsequent aftershocks, which are significant and moving closer to the coast, and the fact that there is currently, as of me talking right now, a tsunami warning in effect from the Pacific Tsunami Warning Center, which is operated out of NOAA, for the entire northern California coast and a portion of the southern Oregon coast. Tsunami, of course, is a rapid and sometimes very dangerous inundation of coastal areas following events that displace significant amounts of ocean water. Traditionally associated primarily with earthquakes, but also occasionally with things like volcanic eruptions, undersea landslides or near coastal landslides, anything that can displace a large volume of water either locally or over long distances. Today, of course, we're talking about the earthquake being a potential culprit there. And just a brief caveat that I am an earth scientist. I have studied earthquakes and solid earth geophysics, but I am not an earthquake or tsunami specialist. So as always, I defer to those who are experts in the field. But in my wearing my public science communications hat and my general familiarity with California and its natural hazards, including earthquakes and tsunamis, that is the capacity in which I am speaking with you today. Right now, again, there's a lot of people freaking out because apparently there are fairly widespread evacuations of coastal areas occurring in portions of California, including the San Francisco Bay Area and places even not along the oceanic coast, but also the Bay Shore. It's unclear whether all of these are necessarily warranted given the circumstances. This does not, at least right now, appear to be a situation where a very large tsunami is likely. Nonetheless, it certainly appears possible, based on the most recent warnings, that a dangerous coastal inundation is possible in some areas. The magnitude of the potential tsunami is somewhat limited, but for two reasons that I can tell at this point. One is, while magnitude 7 quake is very significant if you're close to it, it is nowhere near as energetic as the kinds of tsunami-wide, Pacific-wide tsunami generating events that we sometimes see, which are usually up in the magnitude 8 plus range. And again, it's a logarithmic scale, so a magnitude 8 earthquake is vastly more powerful than a magnitude 7. And also the particular vertical displacement of ocean water matters. So the focal mechanism, meaning whether or not it was a strike-slip earthquake where the plates moved parallel to each other like this, you can imagine if this happens at the bottom of the ocean, it's not going to displace the water column on top of it very much. But if you have an earthquake in, say, a major subduction zone where the ocean floor does this in one place and stays in place in the other, a large vertical displacement can then result in a large displacement of overlying seawater. In this case, it appears to be more of a strike-slip event, which is consistent with the most common type of earthquake in the Triple Point region, where major fault lines intersect off the shore of far northern California. It is often what we see on earthquakes in this region that do not tend to generate tsunamis most of the time, or at least significant ones, because they tend not to displace a great deal of ocean water. But I think the warning was issued in this case because it was a shallow earthquake, so there is slightly increased potential for tsunami genesis if that earthquake is able to result in significant shaking all the way near the surface. And then also there was at least some vertical displacement. So although it looks like it was primarily strike-slip, parallel plate slipping past each other without a lot of vertical displacement, there was maybe a little bit of vertical displacement. So I don't think this was ever going to be a very large tsunami, but nonetheless, I think there has been and may continue to be concern of some dangerous immediate coastal inundation. So this is not like a Japan 2011 type scenario by any means, but we have seen that even relatively modest tsunamis in the past 20 years in California and the West Coast have caused damage, injured people, and even killed people. So I think that is the reason for concern. I'm not quite sure that the public messaging from this event, so the emergency activation systems have been activated, people are getting phone calls and texts, and they're broken into television coverage in Northern California. I'm not sure that they have a great deal of nuance. So there's a lot of evacuations being ordered as if there were a large tsunami coming. That does not appear to be the case. So I think this is another case where perhaps nuance in messaging will be hopefully something that's reflected on in retrospect. But let me just check in the most recent information to see. Okay, so as in line with that conversation I was just having, I'm looking at the Pacific Tsunami Warning page, which you can find at literally tsunami.gov. It's an easy to remember one. It does look like the tsunami warning for all regions has been canceled, as far as I can tell. Let's see what the most recent message states specifically, but it looks like it's been canceled. Let's see what we've got, what the message actually reads. It's not the best website in the world, so I have to actually click around. Okay, so yep, the tsunami warning has been canceled for all of California and from Oregon. It's a pretty succinct message. No destructive tsunami has been recorded. So that doesn't mean that there won't be significant and unusual tidal activity, so weird waves and strong rip-like currents and things like that, but it doesn't look like any inland evacuations at this point are warranted, which is not too surprising given the mechanism of the earthquake. Again, mentioning that this was primarily a strike-slip mechanism and it wasn't an extremely large magnitude quake. So if this had been, for example, a magnitude 8 earthquake or something like that on the Cascadia subduction zone, so just north of the region where this quake occurred, even just 100 miles further north or anywhere along the coast of the Pacific Northwest. There is a risk of what are known as megathrust earthquakes in that region, which, as the name implies, they're very large megaquakes that exert essentially a significant vertical motion. Rather than strike slip parallel faulting, you actually see large vertical displacements in these Cascadia megathrust events, and therefore can generate very large and dangerous tsunamis. It is arguably the largest tsunami hazard for the west coast of North America that exists. Fortunately, this was not a Cascadia subduction zone earthquake, and it does appear that the major risk has passed. I do think this warning was probably issued somewhat in precautionary mode before the focal mechanisms and the amount of vertical displacement was fully understood. And the challenge is, if you're near the coast, had this been a major subduction zone earthquake, by the time it was clear that a major wave either was or wasn't going to occur, especially in places along the north coast, it would have been too late to do anything about it. So I think that's why the warning was issued when it was. I do think, though, perhaps for areas that are a bit farther, the messaging, I think, could be there could be some constructive reflections on whether or not the large-scale preemptive evacuations based on the initial magnitude of the earthquake, perhaps. The other challenge is folks were saying initially, oh, well, I don't see any big waves on the local cameras up along the north coast in the immediate wake of the earthquake. The reality is tsunami genesis can actually be pretty complicated, and in some cases, an earthquake can generate a very large tsunami that gets directed in a particular direction, so in a given axial ray away from the quake. So just because one place doesn't immediately see large waves does not mean that a different place, even hundreds or thousands of miles away, might not see large and dangerous waves from a tsunami. So the absence of large waves immediately near the epicenter is not always a sign that there won't be significant tsunami risk elsewhere. So that's one reason why just looking at the local cameras is not always going to tell you what you need to know. Okay, so now that tsunami warning has been canceled for all affected regions, I think everybody can relax a little bit about that, although this would probably not be a good day to go out on a small craft or to go swimming or surfing, because there still may be very erratic, strong currents and waves that will behave unusually and perhaps make it further up on the beach than usual. That's still possible. I think I'm going to share my screen because there's some interesting things that I think folks will be interested to see now, especially given that warning has been canceled. So you're going to see my infinite mirror, and then I will go over. That's not what I wanted to show.
All right,
now
folks.
You're seeing the truly infinite mirror. You're seeing me. Sorry, I'm in the wrong tab here.
Of my
I've got to go over. Well, usually weather and climate office hours, though
Sorry,
occasionally
I'm playing my
other office hour in the background. That's not what I was intending to do. I did not have as much time as I usually do to prepare for this session, by the way. Okay, so now what you're going to see, this is confirmation. Again, this is from tsunami.gov. There is no warning currently in effect. There was previously a warning in effect, but I'm going to close this out now, because there does not appear to be a significant tsunami threat at this point. Here is, here's a map from the USGS of the earthquakes that you're seeing on your screen here. And I do say earthquakes plural because there have been a number of them. The primary one of significance is the one I'm clicking on here. That's the bright blue circle. If I zoom in, you can see where this is relative to the coast. Pretty close to the coast. Eureka is here. And you can see that this was over an hour ago now, but there have been a number of aftershocks, as you would expect for a quake of this magnitude. There's already been a number of magnitude 3 or 4 aftershocks. Looks like there may have been a magnitude 5 one just now. So This one probably wasn't felt because this is even farther offshore, but all of these probably feel like little rumblers if you're in Eureka and Ferndale, Arcata, since they're smaller, but they're also closer to the coast. Little bit of seismic activity further to the east. That's a small one, 2.5, that could just be random. The earthquake that was originally thought to be a secondary 6.0, looks like it was still magnitude 4 near Cobb, so that's still a noticeable shaker if you were in northern Sonoma, Lake County, southeastern Mendocino County. And if we go into that one, we can see the shake map here. Actually, they haven't generated anything for that. I think it may be difficult to generate because it was so close in time to the other major earthquake. But let's zoom in on this one for a moment, the major one we're talking about. So here's a few different things from the USGS. If I look at the shake map, and I'm going to zoom in here. All right, well, I guess I just need to do this. And let me layer off. That's close enough. Okay, so if I zoom in on that major earthquake, of course the strongest shaking was offshore near the epicenter where nobody lives, so that's good that it wasn't on shore. However, although let's see if I can get the, no, that's not going to show. All right, well, essentially the oranges out here are locally violent shaking, but again, that's out in the water, so that's not an issue for on land. Yellows are strong shaking and oranges are very strong shaking. So the shake map from the USGS that I'm showing here, I'm going to bring up my drawing tool, shows a region of strong shaking approximately in this region. So really from just south of Eureka, so this probably wasn't too bad of an event in Eureka, southward to far northwestern Mendocino County. In this region, there were a number of individual seismic stations and accelerometers that did confirm very strong shaking. So these are pretty large percent of gravity accelerations. So again, strong shaking in this region. Fortunately, sort of just avoiding Eureka proper, although there was moderate shaking there, maybe some things knocked over, but probably not as bad as the shaking from some other recent earthquakes. But then again, it might be a little bit worse than some recent quakes here. There aren't any huge population centers here, but of course there are small towns, including Ferndale. And there are a number of highways that are susceptible to landslides. This is officially the wet season, so I wouldn't be too surprised if there are landslides blocking some roads in these areas. But that's sort of what I wanted to show here. The other aspect is the Did You Feel It reports. These are reports from people. This is maybe a slightly clearer map. Again, in this region, there are some very strong shaking reports from people, so that corresponds with the shake map. The reason why there's no reports from here, well, there's probably two reasons. One is this is where the strongest shaking was, and there might actually be some power and telecommunications outages, but also there aren't a tremendous number of people who live here. So a combination of factors there. But there are some confirmed very strong shaking reports, again, not in any major populated areas. And then the last piece I think that's interesting to reflect on here is a tool from the USGS called Pager. So this is essentially a quick initial assessment of the potential harm that comes from a given earthquake. It's a really nifty tool. This is usually issued within like 10 to 15 minutes of a major earthquake. So, this is a really nice, succinct way of summarizing who saw significant shaking. So again, Ferndale and Rio Dell, so about 4,000 people probably saw very strong shaking, so there could be some significant damage there, but again, that's a relatively sparsely populated region. Some stronger shaking, including slightly more places with greater population, including Fortuna, Humboldt Hill, so around 17,000, 18,000 people strong shaking, and then everyone else kind of in the weaker shaking territory. But the more interesting piece, I think, of this Pager tool for now and for future reference is the estimated losses here. So the most likely outcome, according to this automated tool, is no fatalities, which is good. a slight chance that there could be a couple, depending on how things unfolded. There is likely some damage, and the most likely amount of damage, according to the tool, is somewhere between $1 and $100 million. So a bit of a range there, but the estimate probably being closer to the tens of millions of dollars. So this is not by any means a catastrophic quake, but one of the reasons why I wanted to talk about it was to reflect on, and I think I'll bring my own face back up on screen here. One of the reasons I wanted to talk about it is there was a lot of interest here in this event, partly because millions of people in the Bay Area received either earthquake early warning texts, in some cases, or emergency information via various alert systems regarding the tsunami hazard, which, again, to clarify, is now near zero, except advisement to not go in or near the water itself due to irregular currents and waves today. So I think that there's an interesting question about how we interpret this information, given that we knew this was not, say, a Cascadia megathrust quake right from the start. As soon as we knew that there was an earthquake, we had a rough idea of what the magnitude was, where it was, and where it wasn't. And I think that, it's always complicated conversation, whether it's an earthquake or a tsunami or a wildfire or a flood, the correct level of preemptive evacuation. And one challenge with tsunami hazard is you don't always know what you're going to get until, if it were going to be big, it would be too late to get people out of harm's way. So I think that's one of the reasons why there is such a motivation for preemptive evacuations in cases like we saw today. But also there is a hazard, of course, of the boy who cried wolf syndrome, if you will, where there is such a thing as warning fatigue, and so you want to find a balance always between warning people about risks and hazards and not over-warning people, so that people continue to take the warnings they do receive seriously, and also because there are non-negligible harms to false warnings in any context, because of course there are financial losses that occur when you drop everything and businesses close, and there can be there can be physical harm, either because people get into traffic accidents trying to leave, or people, even something as simple as people racing to leave a building and tripping and falling. There can be car crashes. There can be mental health implications, stress and anxiety. So there are, it's always a balancing act. And I think this is an interesting example of where it was initially quite difficult to find information on this event. So I could go to the USGS website almost instantly and find information about the earthquake itself. But I actually had to go through quite a few steps to verify that there was, in fact, a tsunami warning in effect for the San Francisco Bay Area, for example. I was somewhat surprised by this. And, in fact, a shout out to Stormmaster in the Weather West comment section. That was actually the first place where I saw that information. I was eventually able to verify this via tsunami.gov, although not immediately, and it's quite frankly a very difficult website to navigate. It was loading slowly too. And then I think there were a lot of folks who were surprised, in fact, who didn't receive information about the tsunami alert itself, but then received an evacuation order without context. That's always problematic. It's always important to inform people of what the hazard is and why they're being advised to take a particular action. So I think what this tells us is that the ability of state and local entities to issue real-time warnings, advisories, and evacuation messages in ways that actually reach people in real time is improving. So and these earthquake early warnings are getting to people in many cases before the shaking begins, which is good. There will always be some, especially for earthquake early warning, the inherent nature of it, there will always be some false positives, at least in terms of the magnitude of expected shaking. There will rarely be false positives in that there's not actually an earthquake ongoing, but you might get an alert that strong shaking is possible when in fact you don't receive strong shaking because the system has literally seconds to interpret the initial earthquake waves. Send that signal to a computer processor. That computer has to interpret the signal, decide whether or not it's representative of a potentially significant quake, send that information back to the information dissemination system where it has to be broadcast almost instantaneously to all of the cell phones via individual cell towers in places that are potentially affected. And all of this has to happen within seconds. So these telecommunications, of course, process. They send at least through over the air, so to speak, at the speed of light. That's how the telecommunications infrastructure works. But all of these incremental processing steps take at least a few seconds, and so it's actually nothing short of a small miracle that anybody ever receives information about this before the shaking actually begins where they are, because you rarely have more than about 30 seconds, and if you're really lucky, maybe a minute between when the shaking starts, especially if it's a large earthquake far away. But usually it's just a matter of seconds, and people still manage to receive these messages, in many cases, before the shaking starts. The tsunami advisories and warnings are a little bit different, and ultimately evacuation decisions are up to local authorities. So the Tsunami Warning Center does not issue evacuations unto itself. That's not a NOAA responsibility. That's a local and regional government decision that is usually made in advance for different triggers. It seems like, based on recent experience in the Bay Area, there have actually been a couple of tsunami warnings in effect for the Bay Area in the last 5 or 10 years. It seems like, and this is just my interpretation based on what the actions have been, that there is essentially a binary trigger where local governments order evacuations if there's a tsunami warning in effect, period, irrespective of the details. And so that does raise the possibility of potentially overwarning. Because if this had been, again, a Cascadia megathrust earthquake, there probably would have been a genuinely large and dangerous tsunami along most of the west coast. But there are other types of earthquakes that can result in locally dangerous tsunamis as well. And those are always going to be harder to discern, especially given that they're likely to occur closer to the coast and give much less time between the shaking stopping and having to take whatever action needs to be taken to prevent lives and property. So that's going to be an ongoing discussion. But it's, for perspective, we've seen similar issues with red flag warnings. So the city of Berkeley, for example, this year issued a preemptive evacuation for parts of the hills before a fire even broke out, under expectations of quite high, but not really historically extreme fire conditions. And I think that there were questions raised of a similar nature at that time. And so the real question is, in what context can you do tiered evacuations? So get people off the actual beaches, out of those coastal parking lots, off the piers, versus evacuating people who are actually living, more than a couple feet above sea level, which is a bit of a higher bar. And the challenge is, can you get enough information in real time to make that decision efficiently? I think it's tough. So I never really want to second guess anyone in the emergency operations space in real time, but I'm just trying to offer some context for why millions of people got these alerts, even though there was not really an expectation of an event that was going to adversely affect millions of people in this particular instance, though in an alternative scenario there certainly could have been. And in the initial moments, it's not always clear where things are going to end up. All right, so I'm gonna take a look at some questions that have come in, and then maybe take another look at the earthquake maps, and then I might even, since I have everyone's attention, talk a little bit about the weather at the end, since I was going to schedule a weather-related session for tomorrow, but then this popped up. Let me actually just double check my calendar to make sure I have the time to continue on this. I do, so I will continue on this with folks right now. Take a sip of water. So lots of folks reporting aftershocks, nothing too extreme. Yes, to confirm again, the tsunami warning was canceled. There is no longer an ongoing risk of significant coastal inundations, although it would still be wise to stay off the immediate coastline, meaning like don't go for a walk on the beach, don't go for a swim type caution today, but probably not much need to do more than that at this point. Yeah, as a comment from Sonol that the original warning read like the entire San Francisco Bay Area needs to evacuate. I think they need to refine it a bit next time. I've been talking about that. Unfortunately, I don't disagree, especially based on the visual presentation, which shows the entire Bay Area just in this red, alarming red zone. Even in the very worst plausible tsunami scenarios, of course, not all of the Bay Area is at risk. It's primarily people along the oceanic coast, so the Pacific coast, and then secondarily people who live along the shoreline of San Francisco Bay within a certain number of feet of sea level. So that can be a significant number of people, but even in a very severe actual tsunami scenario, which to be clear is not what we're talking about at this point, there are limits to how far inland a tsunami generated by an earthquake is going to be able to go. The very most extreme tsunami, I think, that affected any significant population center in the modern era was the 2011 tsunami in Japan. Of course, I think it was 2003, the Indian Ocean Basin tsunami. That one was devastating in that it killed hundreds of thousands of people all around the Indian Ocean Basin. But even that, in terms of its magnitude, generally paled in comparison to the peak height of the 2011 event in Japan, which I believe in some locations reached tens of feet, if not close to 100 feet above sea level. So that is about as extreme as you can get for a significant segment of coastline from realistically severe earthquakes, and that's at the extreme upper end of the distribution. That's why that tsunami killed so many people and caused so much destruction in Japan, because Japan is a very prepared nation for these sorts of events, and yet this was just such an extreme event that it overwhelmed even the excellent preparation and tsunami defenses that were in place at the time there. More ordinarily, a bad tsunami might only be 5 to 15 feet of inundation. But the problem is, a lot of folks envision tsunamis as if they are like breaking ocean waves, cresting at the beach, and that is not at all what a tsunami is. A tsunami is essentially like, imagine high tide arriving instantaneously and being 10 to 20 times deeper than the usual high tide. So it is a wall of water, not just a transient wave, but a surge, like storm surge, but faster, of feet of water. Essentially an instantaneous increase in local sea level by however many feet deep the tsunami is tall. And that is very different. So you hear about, 20, 30-foot breakers on the coast. Those are big waves, but they don't make it very far inland because the wave is breaking. It's not a sustained surge of water 20 or 30 feet deep, as a tsunami could potentially be. And so that's why tsunamis are a lot more dangerous and have different physical hazard characteristics than large ocean waves. And also why even a relatively small tsunami on the order of just a few feet can still cause significant damage and be dangerous to people's lives because, again, it's not like a 3-foot little breaker at the beach. I mean, if it was just a 3-foot breaker at the beach, you could easily walk through it in most cases, have some disappointing surfing lessons. But a 3 or 5-foot tsunami is actually quite significant in that, again, it's more like a temporary elevation of sea level by that much. And so you can imagine anything within 3 to 5 feet of sea level can get flooded quickly. And so it's not just that it gets wet, but that it happens quickly. And so there can be a lot of kinetic energy in that incoming surge of water that can cause more harm than, say, if it was a gradual onset. So that's why that's sort of how tsunamis work in general. But I do think, much as I think I personally believe there should be better differentiation of low versus high-end red flag warning. So the difference between, yes, fire conditions are elevated today, but it's nothing you don't experience several times a year. So be cautious, be aware, but exceptional measures are perhaps not justified versus an extreme red flag warning, which is something that you might not see for years, where if a fire breaks out, it's almost certain to become immediately life-threatening. There is a difference between those conditions. Same thing with flooding. And this is another challenge where say you're on the Russian River in Guerneville and there's a flood warning. Well, the flood warning would be in effect potentially if the river's just a foot above flood stage, which is a pain and disruptive. It probably isn't anything historic or hugely damaging or destructive or dangerous. But you could also have a very major flood or historic flood on a river, which is 10 or 20 feet above flood stage, and that's a whole different ballgame in terms of threat to life and property. And I don't think these nuances, which are critically important, always get communicated. Sometimes it's a binary threshold. There is a flood or there's not a flood. There's a risk of a tsunami or there's no risk. There's elevated wildfire risk or there isn't. And the reality is it really does matter how elevated these risks actually are in absolute terms, in terms of what we would do about it. This was a classic problem, by the way, which we studied. We published a paper on this a few years back on the original public safety power shutoffs implemented by Pacific Gas and Electric, the utility for most of Northern California, where they were found legally responsible for igniting a number of highly destructive and deadly wildfires, and because of their equipment failures under extreme fire weather conditions, particularly strong wind events, amid droughts, and immediately implemented a policy of essentially just shutting off the power everywhere and anywhere that it got sufficiently windy and dry. And initially, these thresholds for triggering it were quite low, to the point where in the initial year or so of implementation, the power was shut off for many days in many places, not just under the very highest and most dangerous conditions, but anytime the relative humidity got reasonably low and it was fairly breezy. Obviously, a lot of people were upset with this because there were major negative externalities, and since then, the trigger points have increased considerably, and the spatial extent of these outages and the number of the outages have decreased dramatically since 2020. So I think we will probably see movement in that direction, away from overcorrection in a bunch of different places moving forward. But I think this might just be another interesting example of how we sort of move forward with stumbles and starts on the hazard communication front, particularly when the information is very urgent and real time, which is where it's still difficult in the moment to get everything you need to know. I will say that I have been shifting more of my attention over from Twitter or X over to Blue Sky in recent weeks. That platform has really taken off. It still doesn't have in quite the same functionality as Twitter once did, although I would argue it doesn't anymore either, for official information dissemination during real-time events. So government agencies are generally not present on Blue Sky at this point. I hope this changes. Many of them are still active on X or Twitter, even as the information landscape there and ability to sift signal from noise rapidly decreases in that setting. That is still where most of the official accounts, so the USGS earthquakes account, actively posting today on Twitter, as was the NOAA Tsunami Warning Center, as was the National Weather Service, as were local governments. I'm not 100% sure, none of those entities are on Blue Sky, but I did not see any of them, any of that information in real time there today. It was difficult initially to find some of that information on any social platform. And so some of this, I think, comes down to the fact that there's a better networked infrastructure now for extreme weather hazards and also wildfire hazards than there is for solid earth geophysical hazards, so earthquakes, tsunamis, landslides, whatever it is. So I think that we don't have the infrastructure built out in the same way necessarily, even as the real-time emergency alerts for earthquakes and tsunamis via cell networks, for example, and EAS activations, I think, has improved. So it's an interesting thing to reflect upon, how right now our ability to glean this information in real time is quite hazard specific. So long tangent in response to, I think, an important question. So I'm going to skip all the questions about should I evacuate, because at this point the answer generally, unless you're currently sitting on a beach chair within a few hundred feet of the water, my answer is probably no. Let's see here. So interesting reflection that from Mark Spencer that BART, the Bay Area Rapid Transit, is not running trains due to the tsunami warning. So again, I suspect this is, or if it's still in the case, was an automatic trigger to avoid running trains through tsunami hazard zones. And the BART does run through multiple locations that are probably well within the tsunami hazard zone along the San Francisco Bay shore, including trains that enter the Transbay Tunnel. So that's probably one reason why they don't operate trains during tsunami warnings. There are reasons why some entities need to be inherently more conservative than others in terms of risk. So I think that for things like that, I think the bar probably should be relatively low to temporarily stop service. So I think that makes actually potentially even more sense than some of the area-wide evacuations that were earlier issued. Yeah, so folks were talking about how the city of Berkeley just had mass evacuation sirens going earlier to that point. So there's a comment from Sonol that California coastal geology in general is not conducive to tsunamis. That's partially true. It really depends where you are. So there are certainly much more tsunami vulnerable places than California, but there is also a history of deadly tsunamis in California. I believe it was 1962, the major earthquake that caused a severe tsunami up along the north coast. The coastal geography, the places that are at high risk of tsunami inundation in California are decidedly not as broad as in other places, because there's a lot of places where the topography slopes upward quickly, and once you get above about 20 or 30 feet above sea level, you're fairly immune to all but the most extreme tsunamis. That is unfortunately what Japan thought about in 2011, and that's actually why there was the Fukushima Daiichi nuclear meltdown, because they had this nuclear power plant on some coastal bluffs. I think they were 40 or 50 feet above sea level, and so were assessed to have near zero tsunami risk at that height. And they put the backup generators in the basement. The tsunami then actually exceeded that level and then flooded the generators in the basement. And ironically, although the power plant survived a magnitude 9 earthquake and the actual initial tsunami wave just fine, the backup generators did not. And then the power plant overheated and there were hydrogen explosions, and we know the rest of that. But it is an interesting example of how sometimes the most extreme events can overwhelm even quite robust defenses, but also an indication that the local hazard is not always what the general hazard is. In California, there are pockets of high hazard along beach communities specifically. So there are considerable risks in places like Eureka, near the harbor. In the Bay Area, the main risks are actually the only real, there's a couple of beachside communities in Marin, smaller ones potentially, San Mateo, Santa Cruz County, parts of Santa Cruz maybe right along the coast, but the slope upward is enough that it's not most of the city that's necessarily at risk there, just the immediate coast. But there is actually decent risk around the San Francisco Bay shore. There's a lot of infrastructure in the San Francisco Bay Area within about 6 feet of sea level around the bay. Now, while the energy of the tsunami waves that make it into the bay are probably going to be somewhat reduced in most scenarios relative to the coast, you could still see rapid inundation, 3, 5, in a severe scenario, 10 feet deep, and that would flood coastal freeways, some of the BART infrastructure, the runways at San Francisco International Airport, and a lot of other places in the Embarcadero, the piers. So that would still be a major event and even a disaster. So there is tsunami risk around San Francisco Bay. Again, not from this event, to be clear once again, but in general, with a large enough event, there is real hazard there. Not a lot of risk along the central coast because a lot of the coast is quite cliffy there. So I guess you could get a tsunami that causes some coastal landslides, so maybe Highway 1 problems, but other than that, not a tremendous amount of risk. There is then, once again, risk in southern parts of Southern California. So you think about Long Beach, the port there, the populated neighborhoods near Long Beach, in parts of LA County, and then all of the beachy communities in Orange and San Diego counties, Coronado, all of those places are potentially at risk, probably not from the same earthquake event. So all of these are potentially at risk, but probably in different earthquake scenarios. So not all of these places would receive the same level of risk from any given event. But there are pockets of significant risk, and in some places, those do coincide with fairly high population and infrastructure densities. So that is a concern. By the way, most of the places that are at risk of tsunamis in California are the same places that are at relatively high risk of sea level rise in California. And once again, this ends up being places like the San Francisco Bayshore and San Francisco Bay Delta region, to a slightly higher extent for sea level rise than tsunamis in the Bay Delta context, but and then also pockets of coastal Southern California, so parts of LA County, including Long Beach, and then the coastal communities in Orange and San Diego counties. So there is actually overlap between that climate change hazard, just to bring it full circle, and the tsunami hazard, because the primary consideration there is your distance vertically from sea level and connectedness to a coastal, an oceanic body of water. So even though, say, Oakland Bayshore or San Mateo Bayshore coastline is not directly ocean connected, a tsunami surge can travel through the Golden Gate Strait and into the bay. And so there is risk even in places like coastal Marin County, in the lower elevation neighborhoods of places like Sausalito and San Rafael, the Highway 37 corridor connecting Marin and Sonoma to the East Bay. Again, all the same places that flood during major winter storms or at risk of sea level rise would potentially be at risk from a tsunami. But not today, it appears. Let's see here. I'm just continuing down to look at the remaining comments here, and then I will talk a little bit about the weather. I think we'll have time at the end. There's a question about the chance for another large earthquake. I will answer that in a moment. I'm saving that in reserve. So Bill Locke mentions perhaps what's needed is an immediate tsunami watch, then follow-up warnings. That is, in fact, how the system is designed to work. So California has been under a tsunami watch that never became a warning multiple times in the last decade. And I think what happened in this case is that the earthquake was so close to shore, and the estimated arrival times of any waves that were generated was within minutes to less than an hour in most places. It was probably determined that there wasn't time to issue a watch, that they would issue a tentative warning and then downgrade it if needed, which I think is what happened. That would be my guess. Had there been a Cascadia megathrust quake, my prediction is that there might have been time to issue a watch briefly before confirming that in that case there probably would have been a large tsunami. The watches are also useful when there's a very large earthquake somewhere else along the Pacific Rim. I believe there was one issued in 2011 with the earthquake in Japan. And of course, that's very far away, so the tsunami takes many hours to cross the Pacific. Not as many hours as you'd expect. These internal gravity waves travel very quickly in the interior of the ocean. But still a number of hours before the earliest waves could possibly arrive in California from an earthquake near Japan. I believe in that case a watch was issued and then was upgraded to a warning, I think, because there was a tsunami generated. I'm not 100% sure whether that ultimately became a warning or an advisory, which is a statement regarding the likelihood of potentially dangerous ocean conditions, but probably not a widespread, devastating inundation event. So in that sense, there is a tiered system available, and I think today's event may have just been an example of what happens when there isn't really a lot of time to make that initial determination. Let's see here. All right, so let me bring up, I'm going to share my screen again briefly. Or actually, you know what, before I share my screen, I'm going to take a quick look at social media so that I can see what people are saying at the moment. Just going to see if there are any comments from the actual solid Earth earthquake geophysicists here. Let's see here. Yeah, so I'll make a post in a moment confirming that tsunami warning was canceled a while back. This is the problem, is that sometimes there's just a lot going on and only so many different modes of communication that I can engage in simultaneously. Tweeting, and I don't even know what the term is for posting on Blue Sky yet. I'm not sure if there is a decided one. Yes, it looks like part of the confusion about the tsunami risk actually may have stemmed initially from the fact that the initial plane of motion of the earthquake from the initial sensor information was that it was actually had a lot more vertical motion than it actually did. So perhaps that was why. Perhaps that was actually why the warning was issued. That is interesting. And that does explain perhaps why there was the that's probably why the warning was issued in a precautionary mode, because had that focal plane been accurate initially, then it probably could have generated a more significant tsunami. Okay, so that's what I needed to see there. Now I will share my screen again. Okay, so I'm going to close this. Here is a new map of, so as you can see, a lot of aftershocks. So far, it looks like they're essentially all in the magnitude 2.5 to 4 range. There is a slightly larger one. In fact, this one was, where is it? Okay, that's the one offshore. Anyway, no remarkable aftershocks at this point, and aside from that initial, apparently about 4.0 quake, 4.1 and the triple point, some folks are pointing out that it was not in Sonoma. I think people conflate the town of Sonoma and Sonoma County. In fact, the epicenter does appear, if you look at the map here, probably to have been, in fact, in Sonoma County, but it was very close to the triple point. This is Mendocino County, this is Sonoma, and this is Lake County. So very close to the triple point near Cobb. But technically, yes, in Sonoma County, but instead of a 6.0, it was more like a 4.1, which in that part of the state is pretty ho-hum, arguably. So the official magnitude of the quake off of Mendocino looks like it's settled at 7.0. Sometimes it bounces around a little bit while they do initial measurements, so that's a pretty big one. We'll look at the shake map again, or actually instead I'll look at the pager map. Yeah, so this hasn't changed too much. A slightly expanded region of very strong shaking. So again, it looks like the places that we're most likely to see meaningful damage are sort of in this region. So it does overlap with about 5 or 10,000 people living there, but in general, no significant towns size-wise in this region. Stronger shaking in parts of this area where there's a few more people. Okay, and then maybe I'll talk a little bit about the weather. How about that? Now that I think things are settling down. Okay, so switching gears a little bit in the last, let's just call it the last 10 or 15 minutes, and then it'll be an office hour plus. What have we been seeing recently? Well, in California, it's been relatively warm and dry. In fact, some places that haven't been trapped under a foggy layer have been near record warm temperatures. And we can see this reflected if we look at the broader map showing, let me zoom out actually and show North America. So this is going back in time. Yes, this is going back. Well, actually, this is not going back in time. Never mind. This is essentially right now. So let me actually just bring up. Okay, so this is right now. This is back in time. This is going back to Monday. A broad ridge, center of the Pacific Northwest and Western North America generally, has persisted and strengthened and actually shifted westward a bit. So this is where we are now. A strong ridge across British Columbia. Further strengthening and westward shift of the ridge to be west of California in the days to come. So this is Friday, Saturday. The axis, though, changes. A low-pressure system tries to make it inland. Pacific Northwest does not make it to California, but becomes a bit of, and now I'm going to zoom back in, becomes a bit of an inside slider. So this is that inside slider system I'm talking about. It's resulting in an offshore surface pressure gradient. So there are going to be winds like this. It's a little bit counterintuitive since this is the ridge and this is the trough. But if we shift to the surface variables, which are what matter for the surface level winds, so this is classically what we see with an offshore wind event. It's for Southern California. High pressure at the surface to the east, setting up a pressure gradient like this. So this will be kind of a classic Santa Ana wind event early next week. This is Monday, Tuesday next week, and it could be pretty strong. So this may set up some elevated fire weather conditions in this part of the state. Well, I'll be more specific. In this part of the state, the west and south of the mountains, where there has been very little precipitation so far this season. In fact, we're near record dry start to the season down here. So record wet start to the season around here, above average start to the season in general north of I-80 so far, below average start to the season south of I-80, and almost no rainfall so far this season yet in coastal Southern California, so that will be a potential fire weather risk early next week. Fire season not over yet in Southern California still until the significant rains arrive. This is again what that inside slider trough looks like. And then the ridge persists, going 7-8 days out. It's still here, although it's weakening. And then finally, as we get towards mid-December, so the middle of the month, we see a change in the pattern towards, instead of a ridge, a trough. Not a particularly strong trough necessarily, but a trough on average nonetheless along the west coast. Not necessarily super persistent. Maybe it even goes away again as we get closer to the winter holidays. But what does this look like temperature-wise? Well, right now, recently, we've been seeing this pattern of, you can see it here. This is what I was talking about during the last blog post and office hour section, Unusually cool temperatures just in the middle of the Central Valley where there's been a Thule fog layer, but much above average temperatures virtually everywhere else in California above the inversion layer and outside of the fog. As things have dried out a little bit, even that might start to fade in the coming days as temperatures become warmer, relatively speaking, even in the Central Valley, although actually I take that back, never mind. It looks like that cool weather in the Central Valley, that Thule fog layer perhaps persists for much of this week, even as other places stay warmer. Cooler temperatures with that inside slider earlier next week, before things warm up again thereafter, heading towards mid-December. But at this point, the weather pattern could become a little more active. We could start to see more widespread rain with temperatures closer to the long-term average, neither particularly warm nor particularly cool. And then right now, some indications that warmer temperatures rebuild again by later in December, although that might not be dry conditions. That might be slightly warmer because of the moisture. Let's take a look at the expected precipitation again. This is on a 24-hour moving average basis. Nothing at all to show for it 7 or 8 days out. Slight chance of maybe some wetter conditions as we get towards the 13th in NorCal. But then expanding a little bit as we get past the midpoint of the month. Nothing dramatic looking right now, but definitely a less ridgy pattern than recently. Still no slam dunk signal, and if you average the total amount of precipitation, there's very little, if any, out to 7 days. This is 7 days. We go out to 10 days. There's maybe some light precipitation possible in parts of Northern California, though no slam dunk. And then as we go past mid-month, the wet signal does increase a little bit, at least the Central Coast. Notably, though, still not much to speak of, if any, in Southern California yet. So we'll see how that goes. But right now, no particularly dramatic weather on the horizon. At least another week of bone dry weather, maybe some elevated fire weather conditions early next week in Southern California specifically. And then perhaps a shift towards a somewhat more active, somewhat wetter pattern, particularly in Northern California around mid-month. But we'll see. No guarantees. The signal is not overwhelmingly strong. Okay, so go back to seeing me briefly in the last couple minutes here. Okay. All right, so I think it's just about time for me to wrap up. Just to reiterate to folks, there was a major earthquake today, southwest of Eureka, magnitude 7. It was primarily a strike-slip mechanism, so parallel faulting, not a lot of vertical displacement, and so therefore the tsunami risk was negligible, and as it turns out, despite the fact that there were tsunami warnings issued earlier, officially by the Tsunami Warning Center within NOAA. And there were sirens going off, emergency alerts, and all of that in the Bay Area. All of that has now been canceled, or should be canceled. So things are going back to normal. I think that was largely because the initial inclination was that perhaps this was not solely a strike-slip mechanism, and there may have been some vertical displacement. That turned out not to be the case. So despite being a shallow, strong earthquake, there was little, if any, vertical displacement of ocean water, and so therefore not much tsunami risk. I would still think that it would be wise to remain off the beaches today, but other than that, I think things will go back to normal. There probably is some damage along parts of the North Coast. There were probably 10 to 15,000 people who experienced very strong shaking, capable of producing notable damage to some buildings and infrastructure. Not devastating damage in all likelihood, but possibly disruptive damage, and there may be some power outages and some telecommunications outages up there ongoing at the moment. So not the first time there's been a significant earthquake up there in recent years, but just another in the series. So thanks for joining live. I think this session will probably take the place of another session that I might have otherwise planned for tomorrow. There is a comment that I need to update the date. Yes, I apparently have done this back in time on October 5th. I'll update the date on this. in retrospect. That was probably just an errant slip of the number keypad. But other than that, thanks for joining, and I will see you all next time.